All right, math apps people. So we had some work with arc length the other day. And the idea of arc length is you're just trying to find how long the curvy section is of a circle. And the big idea to always come back to is that the circumference going around the entire circle is 2 pi multiplied by the radius. Some people also like to use the formula pi times the diameter. Either one is totally fine to use. But that formula only works when you're talking about going around the entire circle. And so the idea of arc length is what is it, how long of an arc do you have? How long of a section do you have when you're only going partially around the circle? And so the big idea behind arc length is that you always want to figure out what fraction of a circle you have. And so that comes back to the idea that a circle, a full rotation on the circle is 360 degrees. So, for example, if I wanted to just go 180 degrees, that equals one half of a circle. And I think most of us totally intuitively understand that 180 degrees, half of a circle. Similarly, 90 degrees is one fourth of a circle. 45 degrees would be half of that. That'd be one eighth of a circle, etc. And if you work all the way down to 1 degree, you see that 1 degree would be 1/360th of a circle. Shouldn't have had the degree symbol there. 1/360th of a circle. In general, what we're really doing is we're taking each angle measure and dividing it by 360. 180 divided by 360 is one half. 90 divided by 360 is one fourth, etc., etc. So, in general, if you have an angle that is A, or technically it's the letter alpha, kind of looks like a little fish. This is what the book uses. If you have an angle, any angle measure, what you do is you divide it by 360 degrees, and that gives you the fraction of the circle that you're talking about. Well, how do you go from the fraction of the circle to the arc length? That's where we come back to the circumference formula. We take the fraction of the circle and we multiply it by how long it would take to get around the whole circle. So this makes sense. If you think about 180 degrees is half of a circle, that means we're going to go half of the circumference. If we're going 90 degrees, we're going to go a quarter of the circumference. So any number of degrees is going to be broken up right here to figure out what fraction of a circle we have. And then right here is multiplying by the length to go around the whole circle. You can simplify this because the top and bottom both have even numbers to just be alpha over 180 times pi times the radius. Okay, so I'll just show you a few examples. We had a problem about a clock with a certain radius on it. So the clock had the radius. Clock, actually, they gave it to us as diameter. So I'll draw this picture out in just a second. So the clock has a diameter of 25 centimeters, and we care about when the hand goes from 12 to 5. 12 to 5. And the diameter, if I went all the way through like this diameter is 25 centimeters. So I'm going to break that up to give me the radius. So if the diameter is 25 centimeters, then I know the radius is half of that, 12 and a half centimeters. And I want to find this angle here. That's my alpha. Find that angle between 12 and 5. One way that I can kind of cheat is I know that the fraction of the circle is just 5 over 12. How did I know that? Because there's 12 sections on a clock, and I'm covering 5 of them. So I could get away with doing 5/12 times 2 pi times the radius of 12.5, and that will work out. Or if I wanted to find the angle, I could think, well, if there are 360 degrees on a whole clock, divide it by 12, and I get 30 degrees per hour. So 30 degrees per hour, and then multiply that by 5, and I would go right here and I'd say, okay, this ends up being 150 degrees divided by 360, because that's the full circle, multiplied by 2 pi times 12.5. These are going to come out to be the same thing. 150 divided by 360 is the same as 5/12. So then pull out my trusty calculator here. Okay, so I'll just go 5 divided by 12. So there's 5 divided by 12 times 2 times 12.5. So this is what I have before I hit pi. So you turn sideways to get your pi button. Multiply by pi. It's kind of on the bottom. And that is what I ended up with. So let's go to 3 significant figures. So I get 32.7 centimeters. And I know it's centimeters because that was my measurement from before. So I just carry that on down there. So that's a little explanation of arc length and an example of it. Let me know if there's anything else I can do to help. So comment or let me know if you need anything.